Hello everyone, welcome to this video. In this video, we are going to look into some of the transformation questions from the recent past papers. The first question is the transformation R denotes a reflection in the x-axis and the transformation T denotes the translation of the vector 3, -1. Find the equation y is equal to g of x of the curve with the equation y is equal to x square after it has been transformed by the sequence of transformation R followed by T. Okay, so the equation of the curve given is y is equal to x square, and we are applying the sequence of transformation. First is R. R is nothing but the reflection in the x-axis. Okay, so suppose y is equal to f of x, then the reflection of the curve in the x-axis will be y is equal to minus f of x. So y is equal to minus of x square, which is nothing but minus x square. Okay, then the transformation is T, which is nothing but the translation of the vector 3, -1. Along the x-axis, 3 is the translation factor along the x-axis, which is nothing but replace the value of x by x minus 3. Then the translation along the y-axis is -1. Okay, so with this equation we need to add, it is -1. Then the B part of the question is find the equation y is equal to h of x of the curve with the equation y is equal to x square after it has been transformed by the sequence of transformations T followed by R. So first transformation applied here is T. And again the equation of the curve is y is equal to x square. So translation along the x-axis by the factor 3. So x will be replaced by x minus 3, the whole square. And along the y-axis is -1, so -1. Next is a reflection along the x-axis. So y is equal to minus of f of x, which is nothing but minus of x minus 3 the whole square, and minus of -1 will become +1. State fully the transformation that maps the curve y is equal to g of x into the curve y is equal to h of x. So y is equal to g of x, which is y is equal to minus of x minus 3 the whole square minus 1, and y is equal to h of x, which is nothing but y is equal to minus of x minus 3 the whole square plus 1. Okay, so this is transformed into this. So what is the transformation we are going to apply here to get this? So here this term is same, and here it is -1, but here it is +1. Okay, if you add 2 with this -1, you will get a +1. So that is nothing but the translation along the y-axis by the factor 2. So translation by the vector along the x-axis, there is no translation, so y-axis it is 2. So 0, 2. Okay, with this if you add 2, you will get this. The next question is, the equation of the curve is y is equal to x square minus 8x plus 5. Find the coordinates of the minimum point of the curve. The minimum point of the curve can be found by finding the dy by dx and equating it to 0. So let's find out what is dy by dx. 2x minus 8. Okay. And this is equal to 0. So 2x equal to 8, or we can write x equal to 4. Okay. So we need a coordinates. So what is the y value? When x is 4, y is equal to 4 square minus 8 multiplied by 4. For x I am substituting the value 4 plus 5. So here y is equal to 16 minus 32 plus 5, which is negative 11. So the coordinate is 4, negative 11. The B part of the question is, the curve is stretched by a factor 2 parallel to the y-axis and then translated by 4, 1. Find the coordinates of the minimum point of the transformed curve. So we want the transformed minimum point. The curve is stretched by a factor 2 parallel to the y-axis. If you stretch the curve parallel to the y-axis, that means only the y value will get changed. There will be no change in the x value. So 4, negative 11. Stretched by 2 parallel to y-axis. So you get 4, 2 multiplied by negative 11. So we get 4, negative 22. Next, translated by 4, 1. When you translate along the x-axis by the factor 4, you'll get 4 plus 4. Okay. And along the y-axis, translation factor is 1. So minus 22 plus 1, which gives 8, minus 21. The next part of the question is, find the equation of the transformed curve. Give the answer in the form y is equal to ax square plus bx plus c, where a, b, c are the integers to be found. So find the equation of the transformed curve. So what is y? Y is equal to x square minus 8x plus 5. The first transformation applied is the stretching by the factor 2 parallel to the y-axis. So y is equal to f of x will become y is equal to 2f of x. Two times x square minus 8x plus 5, which is 2x square minus 16x plus 10. Next is a translation. Translation along the y-axis means x will be replaced by x minus 4. Along the x-axis by the factor 4, so x minus 4. Minus 16 multiplied by x minus 4 plus 10, Along the y-axis it is 1. So plus 1. So let's expand this one. So 2x square minus 2 times 4, which is 16x plus 16 multiplied by 2, 32, minus 16x plus 64 plus 10 plus 1, which is equal to 2x square minus 16x will be minus 32x plus 32 plus 64 plus 10 plus 1. 96, 106, 107. So this is of the form y is equal to ax square plus bx plus c. 2x square minus 32x plus 107. The next question is, the diagram shows part of the graph of y is equal to sine of a multiplied by x plus b, where a and b are positive constants. State the value of a and one possible value of b. The graph represents y is equal to sine of a multiplied by x plus b, which is a transformation of the graph y is equal to sine x. Okay, so here it will be 0 and this is pi, and it is maximum at pi over 2. So y is equal to sine x has become y is equal to sine multiplied by a multiplied by x plus b. So in this, a represents the horizontal stretch factor and b represents the horizontal translation factor. So these two are horizontal transformations, so the order affects the outcome. So we need to find the order in which these transformations applied on the curve y is equal to sine x. So let's take a plus xb, a multiplied by xb as x. So x plus b is equal to 1 over a multiplied by x. Okay. So the first transformation applied is a stretching. Then x equal to 1 over ax minus b. Then the translation along the x-axis towards the left side, because the negative sign is there. It indicates the translation is towards the left side. So first is a stretching. So y is equal to sine x has become, after applying the stretching, it becomes y is equal to sine ax. Okay, sine x, the x coordinate value from here to here is pi. Okay, so here this is equal to ax. So let's find out the x value here. It is from here to here. So a multiplied by 5 over 3 pi minus of minus 1 over 3 pi. So which is equal to 5 over 3 pi plus 1 over 3 pi, which is nothing but 6 pi divided by 3, which is 2 pi. A multiplied by 2 pi. So what is A? This pi and pi gets cancelled. A is equal to 1 over 2. Okay. Then what is the value of B? B is the translation factor. It translated towards the left side by a factor of, from here to here it moved. Okay. So here it starts at 0, but here it starts at negative 1 over 3. That negative sign indicates it's moving towards the left side. So B value is nothing but this distance. Okay. Which is 1 over 3 pi. Or pi over 3. The next part of the question is another curve with equation y is equal to f of x has a single stationary point at the point p comma q where p and q are constants. This curve is transformed to a curve with equation y is equal to negative 3 multiplied by f of 1 over 4 multiplied by x plus 8. For the transformed curve, find the coordinates of the stationary point, giving your answer in terms of P and Q. Okay, so let's find out what is the sequence of transformation applied on the curve y is equal to f of x to get y is equal to negative 3 multiplied by f of 1 over 4 multiplied by x plus 8. So here y is equal to f of x transformed into y is equal to minus 3 multiplied by f of 1 over 4 multiplied by x plus 8. So in this, the negative 3 indicates a stretching factor along the y direction. Okay. So this is our first transformation. Okay. Inside the bracket, there is two horizontal transformation. So there the order affects the outcome. So we need to follow the order there. Okay. So here we know the first order is a stretching and then the translation. Okay. So stretching, then translation. Okay. So you can write in this order 1, 2, 3, or it can be 3, 1, 2. Both are correct. Okay. So for the curve y is equal to f of x, the stationary points is p comma q. This is for f of x. And for f of minus 3 multiplied by f of 1 over 4x plus 8, we need to find the stationary point. Okay. So first we are going to apply the transformation stretching along the y direction. So f of x will become minus 3 multiplied by f of x. Okay. So p comma q will become p comma negative 3q. Because when you apply the stretching along the y direction, only the y value changes, x value will not change. Next, we are going to apply stretching along the horizontal direction. So f of 1 over 4x. Okay. When you stretch along the x direction, only the x value changes, y value will not change. So this will become, and the stretching factor is 1 over 4. Okay. When the factor is 1 over 4, it will be stretched 4 times. 4p comma negative 3q. And next we will apply the translation along the x direction, and the translation factor is negative 8. Because x plus 8 is given here, the translation factor will be negative 8, and it is translated along the x direction. That means only the x value gets changed, y value will not change. So 4p minus 8 comma negative 3q. So 4p minus 8 comma negative 3q is the transformed curve's coordinates of the stationary point. The next question is, the diagram shows part of the curve with the equation y is equal to k multiplied by sine 1 over 2x, where k is a positive constant and x is measured in radians. The curve has a minimum point A. State the coordinates of E. This diagram shows the curve with the equation y is equal to k multiplied by sine 1 over 2x. This is a transformed curve of y is equal to sine x. Okay, let's find out what is the order of transformation applied on this curve. So k represents the stretching along the y direction, and 1 over 2 represents stretching along the x direction by the factor 2. Okay, so one is a horizontal stretching, another is a vertical stretching. So the order will not affect the outcome. This is y is equal to sine x curve, and here it is 0, and this is pi, and this is 2 pi. Okay, and it will be maximum at pi over 2 and minimum at 3 pi over 2. Okay, so we need to find this coordinate here, and we know this is 1 and negative 1. So what is the coordinate at this point? 3 pi divided by 2 comma negative 1. Okay, for y is equal to sine x curve, the coordinate of the stationary point is 3 pi divided by 2 comma negative 1. Okay, let's apply the sequence of transformation to get the coordinates of A. So y is equal to sine x becomes y is equal to k sine x. That is, we applied a stretching by the factor k along the y direction. That is, only the y value changes, x value will not be changed. So we get 3 pi over 2 comma negative k. And let's apply the stretching along the x direction by the factor 2. So k sine 1 over 2x. Okay, the factor is 2. So 3 pi divided by 2 multiplied by 2. comma negative k. So only the x value changes, y value will not get affected. So this is nothing but 3 pi comma negative k. The B part of the question is a sequence of transformation is applied to the curve in the following order. Translation of two units in the negative y direction, reflection in the x-axis. Find the equation of the new curve and determine the coordinates of the point on the new curve corresponding to A. So the first transformation applied is a translation. So 0, negative 2. So y is equal to sine k sine 1 over 2x becomes k sine. This is the translation along the y direction. So you will get f of x minus 2, that is k sine 1 over 2x minus 2. So then we are applying a reflection in the x-axis. Reflection in the x-axis is minus f of x. So this will become y is equal to minus k sine 1 over 2x minus of minus, this will become plus 2. Let's rewrite this as 2 minus k sine 1 over 2x. So this is the equation of the new curve, transformed curve, and determine the coordinates of the point. Okay. So initially, what's the coordinate? 3 pi comma negative k. So we are applying a translation of 2 unit in the negative y direction. So only the y value changes. Okay. So 3 pi comma minus k minus 2. So next we are applying the reflection in the x-axis, minus of f of x. Okay, only the y value changes here too. So 2 pi, okay, 3 pi comma minus of minus k minus 2 will become k plus 2. Okay. These two are the final answer.